In this chapter, we're going to spend our time analyzing quadratic functions. In this lesson, we will look at applications of quadratic functions.
Hi everybody. Okay, so in this lesson here we're going to take a look at some applications. So we've talked about parabolas and the equations and the different parts of the parabolas. Now we're going to use that information to solve word problems. But for the most part, what you're going to see here is a lot of times the problems that we're looking at here, when they're projectiles or if it's a revenue problem, we're talking about bridges here. A lot of times in our curriculum here for this course, the expectation is that we're going to use the graphing calculator to find those specific parts of the equation. We'll use algebra to build the equation in some cases. Now, frequently we will be given the equation, but not all the time. But we're going to use the calculator to figure out the answer to different problems here. And I'll show you some examples of this. But first of all, before we get to that, understand that when you graph something, when you go y equals and you enter in an equation, on the Texas Instrument Calculator in particular here, if you press second trace, okay, that is going to open up your calculation menu. Okay, so I'll bring that up here. That's going to open up this menu right there. And that's going to allow you to determine the different features of the graph that you're looking for. Now we just got to make sure you understand what the different tools here mean. So when you press second trace, the first option you get here is value. And what that allows you to do is, in this specifically, you can find the y-intercept here, but basically that just allows you to plug in any x-coordinate you want and it'll tell you what the corresponding y-coordinate is. The zero function right here allows you to find the x-intercepts of the graph. You got to be careful with that though, and we're gonna walk through how that works to make sure that you understand how that works. This one is frequently done incorrectly. Okay, just because people aren't being careful with how they're using their calculators. Typically, it's easy to understand what's going on. You just got to be careful in how you do it. Then you've got the minimum and maximum features here. These are going to help you figure out the vertex, whether it's a minimum, so you got a parabola that opens up, or a maximum, opens down. And again, there's a couple little errors here that do pop up, but it's typically pretty easy to use those tools once you get a hang of it. The next few here, intersect is what you use if you've got two different functions and you're looking for where they overlap. This is not intercept. Sometimes people think you use this function to find an x-intercept or a y-intercept, but this is only if you've got two functions and they're crossing and you're looking for that point of intersection. And then these last two here, these are calculus tools, and so we're not even going to worry about those. Sometimes what you got to do is you got to adjust your window setting. Okay, so make sure that you understand how the window settings work when you press window. This number right here represents the value that is on the leftmost side of the screen. The x-coordinate, x max is the x-coordinate of the rightmost part of the screen. Scale tells you what all the little marks go up by. And then the same thing is true for at y min, y max, and y scale. And don't even worry about the resolution there. That's not a big deal. It really helps the calculator either go through the problem fast or slow. But for the most part, no matter what you plug in there, you're not going to notice much of a difference. Okay? Then finally, before we get into an actual problem here, just up to this point, every time we've looked at a parabola or a quadratic, the domain has been all real numbers. But now we're going to throw some restrictions on the domain because word problems are going to naturally bring restrictions with them. And again, we'll talk about that in a little bit here. We've already talked about restrictions on the range, but there will be additional restrictions because of the word problems, okay? So anyway, we'll talk about that in a moment here. So let's take a look at some examples. Okay, so here's our first problem. It says a frog sitting on a rock jumps into a pond. The height h in centimeters of the frog above the surface of the water as a function of time t in seconds, since it jumped, can be modeled by the function, and here we go, blah, 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 blah. You can read that. Graph the function using your calculator to answer the questions to the nearest tenth where appropriate. And they give us a diagram here. Now, the benefit to the diagram here is that I can see right away what my window settings should be. I don't even have to think about it. I know that my x min here should be 0. And actually that makes a lot of sense. The parabola, think about the frog here. The parabola that it forms here isn't going to actually extend beyond this. The frog didn't come, up from the bottom, from under the ground, and then hit the whatever he was sitting on here, and then jump into the water, and then the frog will not continue, through the surface of the earth to the core. The parabola starts here. The parabola, well, basically ends here. Now, it's really probably going to end here when he hits the water and starts bubbling around here, but it'll probably go for a little bit. And that's probably why that point is there. But anyway, so our x max from this screen is going to be 0.5. My y min, I'll just write that, equals -10. My y max up here is looking like 45. It looks like my y scale here is 5, because every little mark here is going up by 5. And my x scale, what have we got here? It looks like 0.05. Yeah. Okay, so there's all the information here. So now I'm going to plug this into my calculator, and I should be getting the same graph when all is said and done. So here's my calculator, y equals, I'm going to enter this in, negative. And bear in mind, when the negative shows up front, it's this button here, not this one. This is subtraction. If you get an error, it's like a syntax error, oftentimes that's the issue here, is this the wrong negative sign there. So 490 x squared plus 150x plus 25. And now I'll adjust my window settings right away here. So it should be 0 up to 0.5. And this was going up by 0.05. My y min was -10. I believe that's okay. My y max was 45, I think, and I think it was going up by 5s. Now let's graph. That should be, yeah, that looks perfect. That looks wonderful. Okay, now you can also get those the grid on there if it helps you see this clearly. If you press second zoom to go into your format, you can turn your grid lines on. Okay, and if I press graph now, oops, no, what did I do? I didn't do it right. I didn't do it. Hold on. Oh, grid color. I have to change the grid color. Sorry. So if I change that to, let's say, light gray. Sorry, I have them on. They're just not the right color here. Now if I press graph, now I can get the grid. Now you might not want that. But, I mean, now it looks really almost exactly like what we're seeing right here. Anyway, let's take a look at some of the questions now that we're being asked. Okay, what is the y-intercept and what does it represent in this situation here? Okay, well, to get the y-intercept, I'm going to press second trace, and I'm going to use the value feature right here. And it's going to ask me, what is the x coordinate? What is x equal to? Well, it's equal to 0. And when I press enter, now you might not be able to see that. We'll zoom in a little bit here. I'm getting a y-coordinate of 25, and there's the point right there. The calculator's identifying it. So the y-intercept here is 25. Now, what does that represent? Zoom out a little bit here. What does that represent? Well, it's the y-coordinate, which in this case was the height, when the x-coordinate, which in this case is t, is going to be 0. So this must mean that this is the initial height. Okay? When you interpret this, it's not enough just to interpret what the y-coordinate is. You need to interpret what the corresponding x-coordinate is also telling you. Okay? I often see students that when I ask for what does it represent, they'll basically just reiterate that it's the y-coordinate, that it's the height. And that's true, but that's not a complete explanation. It's a very specific height. It's the initial height. Okay? What's the maximum height that the frog reaches? Let's look at the graph again. Go second trace. And it looks like I need the maximum function here because the parabola opens down. Now, my maximum height is about right there. The way this feature works here, it's asking me for a left bound. Now, here's what I often recommend that students do so that they don't make a pretty predictable mistake here. I'm going to move my cursor there till it's roughly on top of the maximum. I don't know if it's exactly on top, but it's roughly there. The calculator is asking me for a left bound. So now what I'm going to do is I'm going to press my left arrow a handful of times and press enter. And what that does is it puts a little boundary marker there, puts a little line. On this version of the calculator at least, it puts a little line there, but almost all of them put the little triangle there. Then I'm going to move back to the vertex, and it's asking me for a right bound, and I'm going to press the right arrow a whole bunch of times, and press enter, and then that puts another little boundary marker there. The vertex has to be in between those two. Okay, so now it's asking me for a guess. Don't worry about that. We're just going to press enter to get past it. That's really just meant to help speed the calculator up in finding it. But you shouldn't notice a difference anyway. So I'm going to press enter. Thinks for a couple moments here. And then here's what we get here. My x coordinate, my y coordinate. Well, this is the maximum value that I'm getting here, which is to the nearest tenth. My nearest height here was 36.5. So this is 36.5 centimeters. And when does it reach that height? Whoops, sorry, you can't see that. 36.5 centimeters. When does it reach that height? What was the x coordinate? 0.2, roughly, seconds. Okay, let's zoom out again. Whoops, wrong way. Now, if your vertex isn't in between those two lines there, like if you inadvertently do it so that your two lines are like over here, the calculator will still pick the highest point in that interval. So if you haven't set that up right, you might think you're getting the vertex when you're not. So you got to be careful that the two boundaries include the vertex in between. Next question here. When does the frog hit the surface of the water? Okay, well, here's the frog jumping. Jumps here, and we're going to assume that the water level here is at 0. So I'm looking at that moment in time right there. So when I press second trace, this time I'm looking for the x-intercept of the graph, so 0. And the calculator, we'll zoom in again, the calculator is looking for a left bound, just like it was when I was looking for the maximum there. So I'm going to do the same thing. I'm going to move that cursor down here, and I'm going to put it roughly on the x-intercept here. And then I'm going to press the left arrow a bit and press enter. And again, it puts this little boundary marker. I'm going to go back to roughly that x-intercept, and I'm going to press the right arrow a few times. Now, I can actually go off the screen here and press enter. What I really don't want to do though is go off the screen to the right here. Some calculators won't like that, okay? I can go off the screen vertically, just sometimes some of the calculators don't like it when you go off the screen horizontally. Anyway, my x-intercept is in between my two boundary points here. Press enter, and it finds it, and my x-intercept here is 0.4. Okay, whoops, this is to the nearest hundredth. Let's take a quick look at that again. So 0.43, 0.43. So at 0.43 seconds. And we'll zoom out again, whoops. Okay. Now, oftentimes I'll see students that are having issues with the x-intercept, and you'll see kind of a weird sort of a message here where there's no sign change. If there's no sign change, that basically means that the x-intercept was not in between those two boundaries when you put them out there. Okay, so just be careful. In this situation, what are the domain and the range? Okay, well, the domain is going to be the set of x values. Okay, and I'm going to do this using set builder notation. I'm going to do two different types of notation here, and hopefully you'll be comfortable with these. Actually, I take that back. I'm just going to use set builder notation for both of those. I'll be consistent this time. It's going to be the set of x values such that, well, the minimum x value that this parabola really makes sense with is going to be 0, because that's when the frog jumps. And then the maximum x value that makes sense in this problem is actually going to be 0.43. Okay, and I'll put comma here where x is an element of the reals. Now, what's going on here is I recognize that the parabola goes on below this, but this is where the frog hits the water. That is really where that parabola is going to stop. Okay, then he starts jiggling around a little bit there. For the range, well, the range is going to be all of the y coordinates. The minimum y coordinate that makes sense in this graph is going to be 0. And the maximum is going to be the maximum height that the frog gets to. And we already figured out that that was 36.5. Okay, where y is an element of the reals. So I'm using set builder notation for both of those. I was going to introduce or talk about interval notation, but it kind of depends on your background whether you've seen that or not. But I think most people will be familiar with the set builder notation. Okay, how high is the frog? 0.25 seconds after it jumps. Okay, so I'm giving you an x-coordinate. I want to know what the y-coordinate is. Well, that is an example of the value feature. Because it sits here and it waits and asks me what the x-coordinate is. So I would tell it 0.25, press enter, and it tells me that the y-coordinate here is 31 point, oh, now did it say to the nearest hundredth? So 31.88. So here I would write 31.88 centimeters. And now, what is the total time the frog is above 30 centimeters? Okay, well, this is a y-coordinate. I'm giving you a height here. This is probably one of the more complicated problems that you're going to deal with here, just because of the amount of work you got to do here. The calculator has a function. When I give you the x-coordinate, it'll give you the y-coordinate, but it's not quite so straightforward when I give you the y-coordinate. This is where you enter the y-coordinates in y equals. So I put y equals 30 in there and I press graph. And I get this line that goes across here. The question is asking me what's the total amount of time the frog is above this mark here. So what I got to figure out is when does it go across it, when does it go above it, and then when does it drop back below it. And then I'm looking for the difference between them. Okay, so if let's just say it goes across at 0.1 second and drops down below at 0.3 seconds, well then I know it spent a total of 0.2 seconds above that line. So there's a little bit going on here. So what I'm going to do is I'm going to press second, trace, and this time I'm going to use the intersect feature because I've got two different functions that I'm graphing here and I want to know where they cross. So right now, my cursor is closest to that point of intersection, so that's what I'm going to find. The calculator is asking me, is it on the first curve? So I press enter to agree, and yes it is. Did it move to the second curve? And yeah, it did. It dropped down. Is it okay to guess this? Well, yeah. What you're going to do is you're going to guess a number that's really close to that point of intersection. Press enter. It thinks a little bit. Okay. And I get this 0.2680. Okay, blah, blah, blah. Now, what I'm going to do here is instead of writing that number down, I do need that number, but instead of writing it down, I'm going to quit. And I'm going to press X and enter. Okay. And so now I've got this number sitting right there. Now I'm going to go back to my graph, and I'm actually going to find that first point of intersection. I'll do the exact same thing. Second trace, intersect. I'm going to move my cursor now closer to this point of intersection. I'm not going to go right on top of it though, just so that you can see what it does here. Is my cursor on the first curve? Yes, press enter. Notice that it drops to the second curve. Is that the one I want? Yes, press enter, and I'm going to press enter to get past the guess. And again, it gives me the x-coordinate of that point of intersection. So that's the second number that I need. That is now in the calculator's memory. So I'm going to now press X again, and I get those two numbers. Now, on this particular version of the calculator, what I can do is I can come up to here, press to choose that, minus this number right here. And I get that, what are they asking for here? Well, it doesn't even ask you, so I'll do this to the nearest tenth here. So the frog here is above that height for 0.2 seconds. Now, if your calculator doesn't have the ability to do this, and there are a bunch that don't, you can always store the first number in a variable by using the store feature and then one of your variables here. There are other things you do. You could write them out if you wanted to. That doesn't take up that much time, really. There's things you can do here. But I just wanted you to be aware that your calculator does, most of these calculators now, the 84 and above here, I have the ability to go back and just grab those numbers. Anyway, I know it took a little while here, but the more comfortable you get with the calculator, the more quickly you will move through lots of these questions. Okay, for the next problem, I'm going to move through this a little bit more quickly because we've seen all these features before, and so I'm just going to assume that you follow along, that you understand what I'm doing, and you're just going to follow along here. So during a high school football game, the height of the punt can be modeled as this function right here. Okay, we've given this to you. Now, what makes this question a little bit different than the previous one is I'm not giving you a graph so that you can identify what the window settings are. I don't know. We're going to have to figure that out. So t is the time in seconds that have elapsed since the football was punted, and h of t is the height, okay, above the ground after t seconds. Okay, so let's pull out the calculator here. And I haven't cleared anything off the calculator, so let's just take a look at what you would do. Let's say this was on an exam. What would it look like? Well, you press y equals. I've already got data in there, so I'm going to clear that out. Okay, and now it's going to be negative 5x minus 1.5, close bracket, squared. And anytime you use this particular button right here to put in an exponent, you got to remember to use the arrow key to get out of the exponent. I can't tell you how many times I've gotten into a pattern of just typing the buttons to get something entered in there and forgotten to get out of the exponent, and then I had to delete a whole bunch of stuff. So please remember to do that. Just make your life a little bit easier here. And then at the end of here, I've got this plus 12.25. Okay, now I know that this is a parabola that opens down, and I know that my vertex here is going to be where the y-coordinate is 12.25. So when I press graph here, okay, I'm just getting this almost like straight line here, but it's because my window settings don't make any sense here. My vertex is going to occur at 1.5 comma 12.25. So I want to be able to, whoops, sorry, you can't see that. I want to be able to see my vertex here, and right now my window settings don't allow for that at all, particularly because my maximum value there is 0.5. Okay, so 1.25, that's going to be the x-coordinate of the vertex. So let's leave the x min as 0 because it's time here. Let's maybe just double that and see what happens here. See if that gets me enough space here to see the rest of it. Maybe we'll go up instead of by 0.05, let's go by 0.5. A y min of negative 10 is probably a little bit of overkill for this, especially if the y max is going to be 12.25. Let's put maybe negative 5 there. And the maximum here, if I put 15 in here, that should be good. Now to go up, to have my scale go up by 5s is maybe, again, a bit of overkill. Let's just maybe go up by 1. And I press graph, what does it look like? Oh, you know, that is pretty good. Now, what I noticed though, there's my x-axis there. I've noticed that I'm not quite crossing the x-axis on the screen here. So my x max is probably not quite big enough. Let's put 4 there and see what happens. But I really do see there we go. That's beautiful. That's probably what I want to see. Okay, so now, what's the maximum height of the football? Okay, well, the parabola opens down, so I go second trace. I'm going to look for my maximum feature. And notice that even though my cursor started to the right here, the calculator asks to find the left bound. So I got to move it over to the left of that vertex first. That's roughly the vertex. Now I'm going to go to the right of it a little bit. Press enter. Press enter. And I get 12.25 as the maximum height. Now I knew that. Okay, I knew that was going to happen. I didn't even have to graph that, but I wanted to walk through that. So 12.25 meters. Now, how long does it take the football to reach that maximum height? Okay, well that was the x-coordinate of the vertex, and that is 1.5. Okay, 1.5 seconds. And again, I knew that because I knew the vertex. So I didn't really need to do the graphing here, but I wanted to walk through that procedure with you anyway. Now, what is the height of the football above the ground when the punter's foot makes contact with it? Okay, that's at the initial instant that this parabola starts. So this is going to be the y-intercept of the graph. Okay, that's going to be the initial height here. So I go value, press enter, and then I let x go to 0. And let's see, what does that get me there? 1. Okay, 1. So whoops, that means that the football is 1 meter above the ground, which makes sense when you think about what it's going to look like when a guy punts it. Yeah, totally makes sense. He'd be holding it in the air and kicking it. Now, what part of the graph represents this moment? We just said here, this is the y-intercept. It is the initial height of the graph here. What's the height of the football above the ground after 0.5 seconds? Okay, well, I go second trace. And then it's time, whoops, sorry, it's going to be the value feature because I know the x-coordinate is 0.5. Whoops, yeah, sorry. Now, did you see what I did there? I went a little bit too quick here. When I pressed the decimal here, I didn't actually press the button hard enough to make it contact. So all I entered in was 0.5 here. Calculator didn't like that. So I wanted to I want to redo that 0.5. And I'm going to get a height there of 7.25 meters. Okay. And now finally, the last question that we got here is after how many seconds to the nearest tenth is the football 10 meters above the ground? So basically, how long is it 10 meters above the ground? Well, that's a y coordinate, so I'm going to go in there and I'm going to enter in my new y coordinate so I can compare them. And that's where it crosses over, that's where it comes back below. So I will press second trace, intersect. And once again, I'm closer to the one on the right, and that's fine. So I'm just going to press enter, enter, enter. And here's the x coordinate that I'm interested in. Just like I did before, I'm going to quit. I'm going to press X and enter, and so that number is sitting right there in the calculator's memory. And in a place that I can access it, press graph, second trace, intersect, and then I'm going to come back over here. I'm going to choose this first one, and again, I just have to move close to it. I don't have to be right on top of it. Enter, enter, enter. There's that second x value that I'm interested in, so I'm going to now quit. I'm going to press X again. So that's the new one, and I'm going to go up, choose the first one, minus the second one, and let's say to the nearest tenth of a second, that football was above 10 meters for 1.3 seconds. Okay, and there you go. Okay, now this next question that we're going to look at here in just a moment here is different than the ones that we've just done because an equation won't be provided. You're going to need to provide the equation. But we've gone through that. Okay, we've gone through the steps for producing equations, so this is not going to be a problem here. But what you got to do is you're going to have to figure out how the word problem fits onto the coordinate plane so that you can create the equation here. And that can be a little bit tricky. It's not terribly difficult, but it can be a little bit tricky here. So, like it says here, sometimes objects, and it's often bridges, okay, are shaped like a parabola. And so we can solve a question about them by putting a grid over top of them. And you've probably seen that before. You see a picture of a grid, a picture of a bridge, and then somebody's drawn the parabola over top of it, and then they grab the information from that. And so that's typically what you got to do here. So when you're solving a problem like that, what you got to do is you got to draw the grid on the diagram to figure this out. And there's a little bit of creativity here because it's totally up to you where you draw the grid here, particularly where you draw the origin. Sometimes a placement of the origin will be more easily used than other places, and so you got to pay attention to that. And so what I do, and when we get to the problem here, I'll show you two different ways that you could go about doing the same problem. So once you've done that, you're going to determine the coordinate of the point of the vertex and form a partial equation, just like you've done before, where the unknown here will be the a. And so you've got a bit of an example given here where the vertex is at 100, 0. So you write your equation, and then again, you don't know what the a is. There's usually enough information, though, that you should be able to figure out what another point is on the parabola. Okay? And then you plug that in to find your a value. You get your a, you build your equation, and then you're going to use that equation to find that other bit of information that you're being asked for, because that's typically how that works. You're going to be given information about some object, usually a bridge. Okay? You should be able to find the vertex and another point on the graph, put those together to get the equation, and then you're going to be asked to find yet another point. So let me walk you through a problem, and I'll do it in two different ways to show you how there really is multiple solutions or multiple approaches to these kinds of problems. Okay, so our problem says that the towers of a parabolic suspension bridge, 200 meters long, okay, so basically it's spanning 200 meters here, are 40 meters high, and the lowest point of the cable is 10 meters above the roadway, so right there. Find the vertical distance from the roadway to the cable 50 meters from the center. So we go up 50 meters and then we go up. We want to figure out what this distance is, okay? Now, that is not going to be the average of those two heights. Even though it's halfway in between the low point and the high point there, it's not going to be the average of those two because this isn't a straight line. It's got a curve to it. This curve spends time, okay, spends some of this distance here without changing much, and then over here it changes a lot more dramatically. So you can't just do an average, you got to figure out the equation of the parabola. Now in this particular case here, the way this is set up, I would think most of you, if you saw this diagram here or you sketched it, would probably draw your axes like this, okay? And so that your origin is right here. In fact, I'm not even going to label that. That's going to be my 0, 0. So now the convenient thing about doing that is this right here is clearly the vertex of my parabola, okay? And when I do that, its x-coordinate is going to be 0. And I'm already told it's 10 meters up here. So I know without putting any effort into it, and I'm going to call this over here method 1 because I'm going to do this in two different ways here, that my vertex here is the point 0, 10. And so I know that my equation is going to be a x squared plus 10. Okay, when I plug that in. Now, of course, I don't know what my leading coefficient is. But I've got these endpoints here on the parabola. And I'm told the distance here and the height. Well, that's exactly what I need. That's an x-coordinate, that's a y-coordinate. So that point right there becomes the point 100, 40. It's actually really easy to read that off because it's almost labeled to me exactly the way I need it. Now I take and plug that in. So 40 is going to equal a multiplied by 100 squared plus 10. Okay, so the first thing I'm going to do is I'm going to subtract the 10. So I will get 30 is equal to a, and 100 squared is going to be 10,000. Okay, and so, I mean, you can probably see this. You're going to divide by, we're going to divide by that 10,000. It's going to be a small number here. So we're going to end up with 30 over 10,000 equals a. And then really in terms of the simplifying, I can divide both by 10 to get 3 over 1,000 is my a coordinate. And so therefore my equation is going to be 3 over 1,000 x squared plus 10. Now let's use that to figure out what the y coordinate is at 50. So if I let x equal 50, I'm going to get y is equal to 3 over 1,000, 50 squared, plus 10. That's just calculator work. Okay, so 3 divided by 1,000 multiplied by 50 squared plus 10. I get 17.5 meters. So the answer is therefore 17.5 meters. Now, I'm going to switch colors here. Let's do this again, but let's put our origin someplace else. So this is going to be my method 2. And I could actually do this a couple of different ways. I could put the vertex there if I wanted, but I'm going to make this a little bit more difficult. I am actually going to put the vertex, or sorry, the origin I should say, let's put it right here. Just to show you what you can do here. So here's my 0, 0. If that's 0, 0, now the first thing I want to do is I want to figure out what my vertex is. Okay, and that's going to require a little bit of work, but again, I'm showing you what you can do here. I know that to go from here to here, where my vertex is going to be 100. Okay, I see that from my graph here. So then the question becomes, well, if that's true, okay, that's easy enough to figure out here, what's this distance right here? Well, this is 40 from the top of the tower to the bottom of the tower, and from the bottom of the cable to the road here is 10. So that means this must be 30, which means my vertex here would be 100, negative 30, because now I am below the x-axis in this particular case here. But that's enough. That's enough. So now I know that my vertex, or my equation here for the parabola should be a multiplied by x minus 100 squared minus 30. Now, I need a point to plug into this. But I was being kind of clever about this because notice that well, remember, I should say, remember that when we were coming up with the equation in vertex form, the one point that you couldn't plug into this to get the answer was the vertex. Well, the origin isn't on the vertex anymore. Or, I mean, it never was in this question, but it isn't on the vertex. So I can actually plug in the origin. So actually, this method here gives me kind of one little lazy step here. I can plug in the origin to evaluate this. And look what happens if I bring the 30 over, and then 0 minus 100 squared is going to be 10,000. And when I divide once again, I get that A is equal to 3 over 1,000. So the stretch factor here, the vertical stretch factor, doesn't change. Doesn't matter where you put that origin there. The stretch factor has to do with the shape of the parabola. So therefore, this goes back to being 3 over 1,000 x minus 100 squared minus 30. Now, if this is my origin, how far over do I go? Well, again, I'm trying to look halfway in between this. I want to do 50 meters from the vertex here. So that's going to be here. And if this is 50 meters, well, this is 50 meters. That's the nice thing about the distances working out the way the question says here. So I'm just going to evaluate this at 50. So y is equal to 3 over 1,000, 50 minus 100 squared, minus 30. Okay, so let's go through and do that. 3 divided by 1,000, 50 minus 100 squared minus 30. Okay, now I'm getting negative 22.5. Okay, negative 22.5. Well, that doesn't make much sense because the question was asking me how far above the roadway is the parabola. And I'm getting a negative number. Oh, that's right, because I put the x-axis up here. So really the number that I got was this number right here. Okay, so I just figured out how far below my x-axis the cable is. Well, if this distance here is 40, and this distance here is now 22.5, in order to get the number that I need here, I'm just going to enter 40 minus 22.5, and there it is, 17.5. And that's my solution.